Hello, everyone, and welcome to this episode. Very excited to be on today's show, especially. Those of you who are new to the channel, my name is Sayam Pathak. I'm a CNCF ambassador working as Director of Technical Evangelism at CIVO. And I basically do cloud native streams with awesome people like you can see on the screen, raw code. So we learn basically the cloud native technology and try to learn new things from the people in the open source community so that you people or I myself included can learn something new each day. So I'm trying to do it each day apart from the weekends, which we should spend nicely and yeah, really excited to be for this one because this today we'll be learning all about Rust. So it's basically introduction to Rust programming. You might know about the language, but you might not know how it works, what it is, what are some of the use cases, and how we'll be using it. So today we'll be learning all about Rust, and we'll basically get start using Rust because we cannot cover. I mean, nobody can cover about any programming language in 1 hour time frame. But yeah, we'll at least get started with Rust, and then we'll carry on from there. So today I have a very special guest, a very good friend of mine, very good friend of mine, David, aka Raw Code. So you must know him from the Raw Code Academy for sure, because if you are in cloud native space, there is a channel, Raw Code Academy, that you must not have missed, obviously. So you must have seen him doing the awesome streams. And so yeah, we both are in the cloud native space. We both share a lot of things, and we both learn from each other every day, and we talk to each other on very regular basis. So that's why very excited to have David on today's show, and welcome everyone who have joined the stream. So excited to see so many folks joining in and wanting to learn Rust. So cool. That is nice. And David, welcome and thank you for giving your time. So please introduce yourself to the community.
Yeah, of course. Thank you, Sam. It's an absolute pleasure to be here. I'm really excited to share Rust with you and your audience. A little bit about me. So I am a developer advocate for Equinix, specializing in cloud native Kubernetes and bare metal. I am an active streamer, as you've already said. I focus on the Raw Code Academy, which is just trying to produce cloud native learning materials so we can all learn this mess together. You know, the landscape grows at such a vast rate that even if you and I put out content every single day, there will still be nuggets that are missed. So it's an absolute difficult challenge, fun challenge, all of the above. But yeah, that's me. And yeah, Rust today. I've already seen a comment in the chat there from Noel that he misread the link as exorcism.io. Yeah, don't do that. It is exercism.io. And it's a great site. I'm looking forward to running through some of the Rust track today so you can all get a little bit more familiar with the language.
Awesome. So yeah, we have a lot of folks joining in. So make sure you learn something today. I'll be learning as well. And let's try some Rust today.
I'm going to try. I mean, I'm going to do, as every good live demo should start with, is the caveats. Is that one, I have used Exorcism in the past before, but I have never worked through the Rust track. So this is the first time that I will be seeing all of these challenges today as well. But they're nicely labeled, as we can see here, between easy, they go down to medium, and then there's some hard ones at the bottom. I'm not sure which ones we're going to do. We'll definitely try and do this in a way that we can cover a lot of the different language features of Rust. And I'll do my best to explain the tool chain, including testing as well as we go. Sam, you're here to ask me as many questions as you can,
Absolutely.
Please. So if I skip over anything or take anything for granted, just say, hey, what is that thing? And I think we'd be remiss if we didn't start with the Hello World tutorial, right? This is where every programming language thing does. So we'll do this here. The way Exorcism works is we have a CLI command that you can install through Homebrew, through apt, through Pacman, pick whatever your poison is, whatever your distro is. You can then use the Exorcism download command to pull down the source code, and you're going to get a piece of code that isn't quite functional yet. And your job, your mission, is to make that code work. So I have already clicked copy, and I have already downloaded the Hello World Exorcism one here for the Rust track. My terminal is large enough there. I'm going to jump into the Hello World directory, and I'm going to pop this open in VS Code, which will show up somewhere. There we go. Maybe. There we go. My computer struggles a little bit with the streaming. I'll have to convince my office to buy me a new one. More cores, please. More cores. All right. So it really is struggling. Maybe shut some things down if it continues, but we'll see. So we have a README here, which just kind of tells you what our... Come on, scroll, computer. I think it's just doing some commands in the background. Yeah, there we go. It seems to have caught up with itself, so maybe I shouldn't open and close VS Code too much. But we have a README file here, which just tells us that our objectives are that we want to write a function that returns a string, hello world. Strings in Rust are so much fun because there's like 4 different types. So we'll do our best to explain that as well today. And that's one of the things that I definitely struggled with throughout my various attempts at learning Rust. We also have a test suite with all of the Exercism challenges, so you can get into the habit of writing tests, understanding how the assertion framework works, and of course running those tests. And then something that Exercism provides here is the ability to then submit your result to the Exercism website, where if you wish to participate in mentor mode, you can actually have people review your code and give you advice on how to make it more idiomatic for the language. This is one of the reasons that I generally encourage people to learn any new language through Exercism, as long as it is a supported language, because it's not just copy and pasting code and writing code, but it's actually speaking to other people that have more experience with the language as well. Okay, so this is the anatomy of a Rust project, and that we have a cargo.toml. So if you're not familiar with TOML, it's kind of like, I guess it's comparable to JSON, but the format has less braces. It has familiarity with INI for anyone old enough to have worked with those files on old Windows machines. But you know, we'll see that we just have key value pairs here where we have addition equals, we have name equals, and we have version equals. If you worked with PHP, this is like a composer.json, but on TOML, package.json from JavaScript. If you're a Go person, I don't really think there's anything akin to this specifically, but I guess it's similar to maybe a go.mod. We have a source directory for our source code, and we have a test directory for our tests. Hopefully nothing too shocking here yet. If we pop open our lib.rs, rs is the extension for Rust files, then we're going to see that we have a function defined. So this is a really, really easy one to fix. Is that code okay? Can you read that all right? Give me a nod, Sam.
Yep.
Yeah. All right. Awesome. Thanks. So we've got here pub fn hello brackets dash arrow thingy. Yeah, there's a little bit of stuff here. So I'm going to go through this really one step at a time. Now, the pub here means that we want to make this function public. It's going to be available to other modules within the Rust code. Not particularly important here because we're not really calling it anywhere, although we'll maybe take a look at the test case in a minute. Next is we have fn. Fn is how we define a function in Rust, followed by the name of the function, hello in this case. And because this function has zero arity, no parameters, we're just opening and closing our round brackets. I guess that's the right name for that. I don't often say that aloud. When we want to define the return type for a function in Rust, we have to have a dash greater than symbol, followed by the return type. This is a particularly special type in Rust. The string is the I guess it's the first string type you're going to come across, and we'll call this hard-coded strings, and we represent that as str. But because these are hard-coded strings, they need something called a lifetime. And this is something that is going to be completely new to anyone that has never written Rust. In fact, I don't think I've ever come across any other language where lifetimes are even a concept. And that may just be that I just haven't worked in those languages. Maybe they come from an academic background. They may be familiar to you if you went through university. I did not. I'm a complete fraud. But I'm going to do my best to explain it all to you now. So everything in Rust has a lifetime, either whether it's implicit or explicit. And a lifetime is how long that value is going to live. And ampersand tick static means that this is going to live for the entire lifetime of the application. So for as long as the application runs, this string will be available. And in fact, anything here, I call these hard-coded strings, and that they're mostly immutable. You cannot modify them. And that is when you should use these types of strings. And they're actually available if you use the strings function on the binary. The operating system will tell you all these strings are hard-coded in the binary. And that is the first type of string that you're going to work with here. So I see we've got a couple of questions that I'll tackle now before we move on with any more code stuff. So, we've got one from Adarsh, which is saying, how is Rust different from other programming languages? So that is a great question, and probably one someone smarter than myself would have led with. But Rust is a strictly typed language, so everything is a type. It supports functional patterns, and that there's no object-oriented stuff here, although we do have something called traits and implementations, which we'll try and touch on today. And it is data race free, and there's special guarantees in the compiler that will ensure that is the case. And this is the main selling point for writing Rust code, is that generally you want a systems programming language that will never crash from data race conditions or seg faults, accessing memory that just doesn't exist. And that happens because Rust has mechanics in place called move semantics that actually track the references and the owners of all pieces of memory, even to the point of moving them when you call other functions. So the Rust compiler will detect that when you pass a variable into another function, it will move it in memory and track that so that nothing else can ever call it at that point in time, preventing you from a whole bunch of conditions that generally would cause your program to crash. That is the coolest thing about Rust. And that'll hopefully make more sense. I'm assuming we're going to get onto functions and maybe the second or third exorcism. Again, I don't know. I haven't done these challenges, but we'll make sure we pick out the ones that hopefully indicate that we'll be talking about move semantics, so you can see how that works. And if I really need to, I'll just type one off the top of my head for a quick demo. We got another question there. Really curious to know the reasons, what make it favorite. Yeah, why do I like Rust so much? The strict types. Wow, they're just super fantastic. Like the language server protocol integrations and being able to autocomplete really intuitively is wonderful. And just the guarantees that the code and my tests passed in the compiler works. It's really unlikely my program is going to crash. And I think Rust is one of these languages that is really, it's an uphill challenge to learn the language, but the more of it you write and the more you adopt the Rust way of doing things, it just becomes really, really enjoyable. In fact, I haven't worked with a language that's enjoyable since Rust, since Elixir. So if you've written any Elixir, that's the journey I've went on. And if you've done the same, hopefully Rust will be a language that you really enjoy as well. So Lakshaya says, what does the ampersand tick mean? This is the lifetime. So these are arbitrary values here. This is just the name of a lifetime that I want. I can actually call this ABC. But static is special, which just means the lifetime of the whole application. If I did ABC, I'd have to give the compiler a way to understand how long ABC is. And they're usually relative to the function or other parameters that I've defined as well. There will definitely be probably some exorcism things on lifetimes. If not, I can also give Siam a link to a video that I did on lifetimes with my friend Anna, which would be really good for people to understand as well. It goes into it in much more detail than I ever could. Okay, I think that is, we got one more question. So where can we use Rust from Anup? Well, you can use Rust anywhere. It's really great for writing APIs and web-driven applications. It has the actor model framework. It's got a web framework called Diesel. It's got one called Iron. It's got one called Rocket. All depends on your background and what you want from a web framework. I know Rocket is really popular with people that came from a Rails backend because it feels very familiar to them. I like Actix because I'm a big fan of the actor framework and patterns. If anyone's familiar with Pony language, I'll talk to you later, but it's a really cool language as well. So you can use Rust for low-level socket stuff. It's starting to be adopted by the Linux kernel for modules, and more of the core stuff coming in there, which is really exciting. And it's been really heavily adopted. Maybe heavily is a bit harsh, but it's being adopted by cloud-native organizations. Linkerd rewrote their data plane in Rust, and we're seeing more cloud-native companies and frameworks adopt Rust there too. Again, because we all want our software to work. And if we can get those guarantees from the compiler, that's a pretty cool feature. Okay. We were doing a hello world task. So you can see here that we have the string goodbye world, which means our test is probably going to fail. And in fact, if we jump back to the command line and run cargo test, I have no cargo. How is that possible? I have no Rust. We're going to learn how to install Rust. So here's a funny story. I installed the macOS 12 Monterey beta thing like 2 weeks ago, and my entire machine died on me, and I had to wipe everything from scratch. And apparently, I didn't install Rust. So that is awkward. What I'm going to do is jump over here. The best way to install Rust is through Rust Up.
Okay, we get to see the Rust installation as well.
Not intended, but yes, we're definitely going to take a look at it. So I'm just going to be really horrible and copy this curl command, which pulls down the sh.rustup.rs script, and I'm going to pipe it into a shell. Rustup is just a command line tool that manages Rust versions for you. So there's Rust Stable and there's Rust Nightly. I'm going to just install Rust Stable. Nightly is where all the new cutting edge stuff happens, new language features, new syntax, etc. You can opt into that if you're a Rust developer. Not something I would recommend doing for writing day-to-day Rust. Rustup will also install Rust docs, the Rust standard library, the Rust compiler, Cargo, which is the package manager and toolchain. We've got Clippy, which is like gives you advice on how crap your code is. So it'll actually tell you, hey, there's a nicer way to write this code. Clippy is fantastic. And I think that's probably all that it installs. So we'll just give that a few seconds. I'll tackle another question just now then from Suman. Did Rust become more popular due to WebAssembly support? Possibly. Rust is definitely at the forefront of WebAssembly. Right in WebAssembly modules, Rust has fantastic support, mostly down to tooling. Rust is designed on LLVM, so it can be compiled for pretty much any platform. And WebAssembly is just another platform there. So it was really easy for the Rust. No, saying it's easy is probably not giving people enough credit for the work that went into it. But the primitives were there for them to be able to add WebAssembly as another platform. And it really is a joy to work with in that environment too. Okay, let's source cargo NV. Ooh, it's green now. Okay, so now we can run cargo test. So that's going to do some compiling. Unfortunately, Rust compilation is very slow. In fact, there are many jokes now about compiling Rust. So while that does compile, we'll jump over to our test. So this is our test file. The things that we need to be familiar with here is one, we have a macro. This will do code injection, which basically just surrounds this function with enough information to let us know that this is a test. And the name of the test is completely irrelevant, and it doesn't need to start with test, but it is kind of the idiomatic way of doing things. We then call a macro inside of the code, which we know from the exclamation mark. So this is an assert equals. And what we want to say is that we expect the string hello world when we call this function from the module hello world and the function hello. We jump over to our test, we'll see that it fails. We get a nice comparison here. On the left, we have hello world, which is what we wanted. On the right, we have goodbye world. Now, I've got two options here. I can be cheeky and update the test to look for goodbye world, or I can update the code to say hello. I'll try and keep things correct for now, and I will do hello world here. Now, Rust has some things in the language to make a few things easier. You'll see there's no semicolon on the end of this line. This just means that it's the last expression in the function, and Rust will return it. We could also do an explicit return with a semicolon if we wanted, Those are interchangeable. That'll be familiar if you come from a Ruby background as well. I'm going to save my code and run my tests. And the tests pass. We have now written our first bit of Rust code. Okay, Sam, looking at Hello World, is there anything surprising here to you? Anything I haven't explained? Or would you like me to move on to our next challenge?
Yeah, I think that was a very neat explanation. Like we have pub, then we have function name, then we have the sign for telling the duration where the value of that particular variable will be staying throughout the execution of the program. And if we define anything else, then we have to define like what that value actually is, like you mentioned ABC. So if we do that apart from static, which for static it means it'll be throughout the life of the execution of the program. And if we put any other value, then probably we have to define that first so that our Rust compiler knows what the exact duration of that particular string would be. And then we have test functions that we can use to test the code. Obviously, before all of these, you have to install Rust.
Perfect. That's a good summary. Well done. All right. Kai left a question in the chat as well. Kai asked, is there any particular reason why the compiler for Rust is slower than some other languages? I think it's just mostly down to the amount of work that the Rust compiler is doing. You know, it's moving things around in memory. It's doing all that data race guarantee stuff. Also, LVM, I think, is typically slower for compilation times. I know the Rust compiler team are working on making this faster, and it does get faster with every new version through incremental compilation and all this other stuff and Magic AST. But that's the best answer I've got. I'm sure there's people, hopefully, that can give a better answer, maybe in the chat or maybe later on Twitter. But I'll see what I can find out. Okay, let's close this down and move on. So we jump over here. I don't have the next challenge yet, so we're going to pop over to exorcism.io and we will pick another one. Oh yeah, I could submit this if I wanted to make sure that it was right. So we should do that, right? Let's get the check mark. Oh, submit dot. Oh, file name. Okay. Okay. Source main. What did I call it? Now we can jump on to the next solution. So what have we got in number 2? We have booleans and conditionals. So that sounds like something we should probably work on. So let's copy this. We do exorcism download. Pull down the code into the Leap directory. And I think just because my computer is struggling a little bit, what I'm going to do is just use Vim. It has no syntax line. Okay, forget that. Let's just open code. See, this is why you should never wipe your computer without proper automation. My automation is good, but apparently I've missed some Rust stuff. Okay, let's take a look at our test first and see what this expects. Maybe. So I have a Rust plugin for VS Code, which every time I open a Rust project runs Rust Analyzer, which is scanning all the code, compiling all the code. It does all this stuff in the background, which is why things are a little bit slow every time I open a new repository. And you can see it down here. Rust Analyzer is indexing and scanning. So I wonder if I can speed this up.
So you also have a project, right? Comtria. How do we pronounce that? The one that
Comtria.
Comtria. Okay.
Yeah. Have you ever watched Stargate SG-1?
Nope.
Ah. All right. So Stargate is one of my favorite TV shows of all time. And there's an episode on it, season 3, I think, called Window of Opportunity, where they go to a planet that puts them on a time loop. No, in fact, that's another one. Comtria is the planet where they go to where they're cloned by robots, and the robot that clones them says Comtria all the time, and then says things are better. And I thought that would be a cool name for a project. And it does automation, is what I have all my dot files and packages automated with, besides except Rust and NeilVim. We'll fix that another day. And it's written in Rust. There are lots of Rust code to use there, hopefully as an example of semi-idiomatic good Rust code. Maybe we'll try and add a feature to that at the end, although I cover some more language features first. So here's our test files. Here's our code. This is using a macro inside of the function, which is called unimplemented, which just means our code will crash when we run it, which we obviously do not want. If we open the README, what we have here is that we want code to be able to work out if something is a leap year. And the way that we do that is if the year is divisible by 4, 100, or 400, we do consider it a leap year. So we're going to be passed in an integer, and we want to return a Boolean value. So you can see here we've got an unsigned 64-bit integer, and we were going to return a bool. If I jump over here and run cargo test, yep, we've got all of this not as we want it to be. So we can delete our unimplemented macro here, and we can start to make some of these tests pass. So they're not really named in a way that make me... I was going to see if I could just make one pass quickly, kind of proper TDD style, but I'll just kind of make it up as I go along. So one of the things we can do is we can say if year divided by 4 equals 0. It should evaluate to a Boolean expression, which should satisfy at least one of our edge cases here, which is that if the year is evenly divisible by 4, gives us 0. That should be modulus 4, right? And if we do cargo test, we have our first passing test. Test a year not divisible by 4 common year. Okay, so we had other conditions. So we also want to check for 100 and 400. So now we can't do this as a single line anymore. We actually need to bring in more Rust primitives. So what we could do is use if statements and say if year modulus 4 and we could do an early return of true, else if year modulus 100 equals 0, return true, else if year, you can see where this is going, 400 equals 0, return true, otherwise return false. That looks okay? You trust me?
Yep.
Let's see. Well, we have ignored tests, so I'll just pop this open. So this is allowing us to kind of bring these in one by one, but I've rushed through the code so we can get on to more fun stuff. So let's and there's a few ways to clean up this code as well. What we have right now is not idiomatic, and I'll talk about that once we get our tests running. There's a lot of different macros and things like that in Rust. Really flexible language for metaprogramming. Let's see what happens. Oh, I can't code. What have we got? So NEOG year passed, exceptional centuries passed, but our year divisible by 100, not divisible by 400. I probably misread the condition here. Oh, okay. Yes, I did. Okay. So every year that is evenly divisible by 4, except ones that are divisible by 100 and 400. So that's what I get for not reading the spec. But I think This means this should be false and false. See if that's a bit happier. Okay, so now we got a failure. Test year divisible by 200, not divisible by 400. Yeah, I'm not sure what I'm getting wrong. I could read the spec properly, but it's not very exciting. So I'm going to make this code idiomatic and we'll just move on to the next one. So the way that Rust works here is that it's actually very rare that we would type a return with a semicolon kind of expression. Typically, we want our code to evaluate to something a bit cleaner. So, it may be that we actually have a multi-value return here where we have an else which returns false 2. And this block would be evaluated as a single return value and in turn be returned as well. This is slightly more idiomatic. We also have access to match expressions in Rust, which I think we'll get to in a minute. But I'm just going to run the test again on this and leave it, and we'll move on to the next one. Even though there are things failing, that's just because I'm not reading the problem domain properly. And I don't think it's interesting to fix some division stuff here. That all make sense to you, Sam?
Yep, absolutely.
All right, cool. Let's grab something else. So we did booleans and conditionals. We can do conditionals and strings. We can do beer songs. We can do proverbs. Let's see if we can get something. Yeah, here's string versus string. So let's take a look at this, because there are multiple string types in Rust, and I think those are quite important to understand. So let's pull this one down.
There are a couple of questions as well, if you want to take them now.
Yeah, I can't see the questions anymore if you want to drop them out. I had to shut down the iPad, which was my display here, because I think it was causing my computer to be slow.
Okay. So basically, the run test in the test file from your Rust, is that Rust VS Code plugin?
It is, yeah. So if I pop open this one here, and then hover over, I need to wait for Rust Analyzer to finish. But yeah, there'll be little magic buttons that show up here that allow me to run individual test cases or run tests for the entire module. This does come from the Rust plugin. There's also a really good one for Go as well, which offers the same functionality.
Okay.
Anything else?
Yep. Why is Rust considered a very safe language for working with memory?
Yeah, it's considered very safe because of the magic stuff that it does. The magic stuff being, in fact, let's show by example. Let's kind of go off script a little bit here. So we'll ignore this challenge for now. In fact, let's create a new off script. We can do cargo init, which is just going to create a new Rust package for us. Should give us a main function that we can run. Rust Analyzer is going to hate me today. There we go. So here's a really simple main print line function. You can do cargo run. Get that compile. There we go. And it prints hello world. Okay, let's add a second function to this where we'll just say add numbers. And we're going to take number 1. We'll call that N1. We'll just see as an unsigned 32 and an N2, which is the same, and that's going to return an unsigned 32. And we can return N1 plus N2. Funny that I've realized why this isn't going to show what I want to show, but I'm also going to walk through it just because why not? So we can call add numbers, and we'll say 16, 16, and we'll print this out. I start writing Go code now, aren't I? That's a challenge when I keep working in too many languages. Okay, so why are you complaining? Let's see. That. Oh, wait, why have I got a comma here? Okay, so now we've added a function. And we should be able to run this just now, and we should see 32 come out on the terminal. Go. So now what we're going to do is pre-allocate these numbers. So we'll say ABC equals 1 and DEF equals 2. And then we'll use these numbers here. Like so. Rust is using something called type inference here. I don't have to provide the type up front. I can let the compiler do it for me. And in fact, you can see here in the little grays that it's telling me we have unsigned 32-bit integers here. I could override that like so, and it's just as valid. So it really comes down to preference on you as a developer, whether you want to be very implicit or very explicit with your types. We can run this code again, and we'll see that we've got our new value from the 2 that we defined here. I'm going to just copy and paste this code. This will still work, which is why I was laughing in my head, because I was trying to show you an example of where this wouldn't work. Now, this is because Rust has some zero-cost abstractions that these numbers just live in memory. They don't cost us anything to move around or copy or anything like that because they're primitives. Let's change this function now. I'll copy out this code first. And we'll do let ABC equals a string from ABC123. I'll do the same down here. EF456. Change this function to take string types and concatenate them together. So this time we'll have add strings. And this is our second string type as well, which I'll explain in a moment. I'm going to return a string. I actually don't know if that'll work. No, it won't work. One. Is there a concat? No. I'm going to cheat. 2, 2, 1, 2. There we go. Now we have a strings function which will add them together. This format is a macro that allows us to format multiple strings together. There's a whole bunch of functions that happen through traits on the string object, as we can see here. There's no concat. I'm sure there's join or something else there that I could have used. Apparently, I don't often join strings together. There's push. Yeah, I got to use something else, but I'm going to use format. So now we can come in and call print on our add strings. C, D, E, F, and then do the same here. Now, this doesn't work. This is the same code as the integers, but we can actually see the red squiggles here. And what this is telling us is that we can no longer use ABC and DEF because they're removed. Now, let's try and break this down. One of the things that's really cool about Rust as well is that the error messages are fantastic. So whenever something is broken, let the compiler tell you what it is. It'll also give you suggestions on how to fix it. Okay, so there's a few things to unpack here. First, second string type. We looked earlier at, let's call this stir1. And this is the ampersand tick static hard-coded string. These cannot be changed, and these are immutable. So whenever you want to work with strings that you want to be able to mutate in some way, we then have to use strings of a different type. And that would be string1 equals string from hello. There's a whole bunch of ways to actually instantiate them. You can do string2 equals hello dot to string. So, but they all evaluate to the same uppercase string type. So the good semantic to use when writing Rust is if it never has to change, just use quotes. If you do need to be able to pass it around, mutate it in any way, shape, or form, you're going to want to use uppercase strings for that. A whole bunch of cool features where we can actually do string, replace, where we say replace E with Fs. And we can work with strings this way. Okay, now our error message down here. Why is this a problem? Well, what happens when we call this function the first time? Sorry, my thing is highlighting it, but when we call line 13, when we call add strings, we actually lose access to ABC and DEF because they've been moved in memory, and now the owner of those values is our add strings function, which means by the time this function is finished, we actually no longer have valid references to ABC or DEF. In fact, if we do abc.replace down here, it's going to tell us the exact same thing. So what does it say? Well, it says borrow of a moved value. So there are a few ways to get around this in Rust. We have the concept of passing things to functions temporarily as a borrow. And we can do that through ampersands here. And we need to, and we'll just print them out like so. Cool. And I'm getting yellow squiggles because this is all essentially dead code. So let's just remove it for now. So what happens on this version of Rust? Well, we still allocate ABC and DEF. We're now passing a reference to ABC and DEF, denoted here by the ampersands, which means we're given add strings functions the read only, the ability to read these values only and not mutate them, so that they're still available to our original host function further down the stack, as in lines here. That's it. And in fact, if we try to do any sort of modification on our string down here, it should give us an error saying that we do not have ownership of the value. It cannot be modified. An error message Rust. Have to be cloning it for me. We'll ignore that. In fact, let's just do an assignment. So let's do s1 equals string. Oh, that would do a read. Yeah, never mind. So does that make sense?
Yep.
I think there was quite a lot there, and I feel like I rushed it, but hopefully it kind of made sense.
No, I think there are a couple of questions that are there, but not related to this particular code, but in general. From Carlos. So Carlos has also joined the stream. There are a lot of folks that are there. And is there a way to get intermediary code like C, C++, or there is no intermediary?
So all LLVM languages do compile down to an AST. So there are ways, there are intermediate codes. I'm not sure they're entirely human readable. There's also FFI if you need to be able to call C or C++, but although it does require unsafe markers like this in your code to tell the compiler that you don't care that it crashes, essentially, or that it may crash or bad things could happen.
And what is the difference?
Sorry, Indigo.
What is the difference between borrowing and moving in Rust?
So kind of what we're doing here is that when we borrow, we're passing a reference to an original value which cannot be mutated. So the function cannot make any changes to it. And there's an automatic reference count that happens. So the compiler knows how many references there are. Although I think unless you're doing magic stuff, there should only ever really be one reference for the thing. And then you have the ability to then mutate that again where the ownership resides. So right now, the ownership for A, B, C, and D, E, F resides in this scope here. And down here, we have a read-only reference to both of those values. Now, there are the ability to break out of that, and that we could do DEF equals s1.clone. Clone is your get out of jail free card whenever you need to be able to mutate a value, and this will actually copy the value onto the stack. So it will take up double the amount of memory, but you will have the ability to make modifications to it if needed. I answered that question.
Okay. And one more is there, like how to declare or import packages in Rust?
The module system. Yes. I think we're going to need to do a 5-hour stream on this, to be honest. Okay. So we could define new modules. Let's start with hello.rs here. And this becomes a mod called, mods is how we pull something in. Let's have more. Let's have hello world. So we can define a pub function here called hello world. And we'll just use a print macro. Hello world, like so. So now in our, that was in world.rs, and we've made it public. So in hello here, we can actually say that we want to make world available. And then in our main, we can consume those modules. So, and now we have access to hello. Why are you complaining? I do have world. I'll just put it in here. I think it's complaining because I'm not using a directory structure. Now we'll put this in here. We should be able to do world, hello world, and we've got our function call here. And when it comes to external packages, we've got creates.rs. That's creates.rs. Changed. This is very new. This was creates.io. Cheeky. That's changed a lot in the last 24 hours. So now we can search for packages that we might want to be able to consume in our own application. I'm going to just use one of my own here. So I have this GitOps operator in Rust called gitsync, where I can copy this here, drop this into my cargo under dependencies. That will then pull in the dependency for me. And then if I jump into our main.rs, we can say use gitsync. And now, if the Rust Analyzer has caught up with me, it's not, I would have access to my gitsync methods. So I think cargo is still doing some checks down here before I have access to this. Yeah, I don't think it's pulled it through yet. Let's do a cargo build, try and speed it up. Yeah, it's still waiting.
Yeah, so that at least gives the gist of like how to use different packages, or basically the modules within the package, and even the external one. Just like you showed, by adding to the dependencies in the cargo.toml file. So that's how you can use the dependencies. So I think we have learned with the basic Hello World program, basically the function structure, how you can define a function, then how you can do some of the conditional operations in a function, how you can work with strings, and how you can what do you mean by borrow? So you can borrow and you can do a read-only value of the above or the previous variables that you have defined. So we have learned that, and we have also seen the some of the modules that you can create within your folder structure or the directory structure and use that, and also the external ones that you can define in the dependencies. Interesting.
Yeah,
that's a lot, right? That's not less.
Yes, there is a lot in Rust, and I mean, we have what, 12 minutes left? Is that right?
Yep. And I was thinking like, what would make sense now to continue another problem, or you want to showcase like CompTria, like how a tool can be built using Rust with some of the fundamental programming that you will be learning, so you can have some of the use case like you did and create some project like the one that you already have.
Yeah, so that's a good idea. Let's jump over to CompTria, which I bet you still need to clone. Now, we won't have time to add a feature, but what we will have time to do is to take a look at more of the Rust language. Hub.com, CompTria. Because there's some really nice features that we've not even touched on yet that I think would be good to point out, like monadic types and match declarations. Like these are really idiomatic in Rust, and like if you want to write good, clean Rust code, probably the best features to kind of be understanding. So let's pop open. Now here's the module system in play. You can see here I'm using a whole bunch of external crates. So we use the use statement to pull those in. These are all defined in the cargo.toml. We have our mod keyword here. So in Rust, no code is compiled until it is linked from main.rs or lib.rs. Those are two very special files. So when you add new directories and new code to your project, nothing actually happens until you consume it in one of your files, which is why you'll see mods like this to bring that code into scope. Now, here's an interesting line as well. This has got a bunch of features that we can want to be able to understand. So first, we have const values, and we have an option type. So this is a monadic type in Rust where we can say that we may have something, but we may not have something. And this is something that you will use a lot, especially in its result form, where we say that we have a value which could be okay or an error. And there's lots of examples of that in this code base too. Rust and metaprogramming seem to go hand in hand. You'll see that we use these kind of macros on functions and structures a lot to infer and generate boilerplate code that you just don't want to have to do yourself. And what we're actually saying here about the structure is that first it's public and it's called opt, but that we want to derive some functionality. We want to be able to derive, clone, and debug. This just means that it's going to generate some implementations so that the code can be printed to a terminal or even cloned when we want to move it around in functions, but we only have read-only references. What else do we have? Now, I won't go into struct-op. It's a really cool library for building CLI applications, but there's just far too much of it to cover. Here is our first match statement. So you will see a lot of match statements in Rust code, but it allows us to do like a switch case you'll probably be familiar with in other languages. Only you can do destructuring and stuff like that inside of a match statement. This one here is really, really simple, but there's infinite power and flexibility in match as well. Here is our result type. So here we're saying that this function will return an OK value with open and close brackets. This threw me when I was learning Rust, but it's just a none, not a none. That's really bad phrasing. It's just a generic nothing type, but not none. It basically means OK, but I don't have any value. And I'm sure Rust developers are going, it's called this, but I can't remember what it's called. Let's see, we've got if statements. Yeah, this is all pretty thing. Okay, cool. And then with Rust, we get into iterators. Those are a really big thing in Rust because we work with vectors and slices, just like we do in Go to a certain degree, where we have to be able to iterate over them. So what we have here is a function called manifest register providers, which we can turn into an iterator, which means we can use functional composition to filter and fold the values, exactly like I'm doing here. So I'm basically just saying loop over this iterator, and if any value looks familiar, we want to filter it out, and then we fold it down so that we just pick one value out. Now, if you don't have a functional programming background, filters and folds and reduce, these are just really terms that you get used to over time. The Rust documentation is fantastic here as well, so I guess we should probably take a look at that. But we can go to docs.rs. We can type vec. Nope, that didn't work. What would be a good library? Go to struct-op. Let me down Rust. Let myself down for getting it wrong. There we go. Yeah, so docs.rs has the documentation for all Rust crates, and it's always got examples. My libraries do not, which is why I did not search for git sync. I really should be better about that. But these are all built in with the documentation into Rust code. There's really good dot block syntax that allows you to embed all of these examples and show how it all works and stuff. So it's always really handy just to know that docs.rs exists, because it should be one of the first places that you go to for help when the error messages aren't enough or the LSP isn't enough or anything like that. Really, really cool. My computer's slowing down again. I think it's trying to compile come try it just now. What we got? Let's see if we can find some traits in here. Traits are one of Rust's other secret powers, or superpowers as well. So I want to make sure that we cover that. So let's take a look at here. Okay, so because Rust is more functional than it is object-oriented, we have this concept of a trait. Now, a trait just means that we're going to define a trait of behaviors or set of behaviors that other structures can implement so that we can have a sort of generic composition or generic function calls on those structures themselves. What I have in Contraya is a trait called action. And all I'm saying here is that for something to be considered an action, it must implement this function call. A function call here is just plan, where it takes reference to itself. So this is the structure. And you'll see this is a reference, so it's read only. It cannot modify itself here. It also takes something called a manifest and a context, and it's going to return a vector of steps, which is what the plan emits. So it's just, here are the steps I need to do to be able to action this plan. And then you can implement this trait on any structure, which means if we pop open, let's take a look at our command. We have a structure here, just like in Go or C++, anything like that. I guess that would be a class, but maybe C, where we have some fields on it. So we've got a command, which is a string. We've got some args. We've got pseudo, whether it's true or false, and we've got a bool. But then we can implement action for this structure. Now, what does that mean in code? Well, it means if I have, I'm going to break everything here by trying to do this, but let's say that we have some CMD, which is a run command, and we autocomplete this out with some values. If my autocomplete was working, right? String from ls, args to emptyvec, pseudo false, and there none. Now, because this is an option, we don't need to set a value, so we can use none instead. But this is just a data structure with no concept of functions. And because it implements the type, we could call the plan here and pass in those values. And that glue happens through this implementation of the trait on the structure. And that's what that line here means. Let's delete this so that we can here. We just have to replicate the same function signature from the trait itself. Of course, VS Code can automate all of this. You barely need to do anything except type the bit in the middle, and then we just emit the vectors that it expects, and we can run that plan. So traits and implementations of traits are definitely one of the things in Rust that you should get familiar with really, really early, because it's going to allow you to make code that scales not by like numbers of how many requests, but just scales as people join the project, and maintainability and health of the project longer term, because the code is going to be generic enough that you're not hard coding too many bad practices. So I always encourage people to look into traits and implementations as early as possible in their Rust journey. Sorry, that was a lot to throw at you in like 8 minutes.
Yep. That was a quick run through, but that was a lot of information to digest, to be honest, and don't know how much people would be able to do so in the last 10 minutes of the stream when they'll be watching later as well.
Yeah, I mean, there's a lot in Rust. You know, we've barely scratched the surface of it. You know, I would encourage people to use Exorcism and run through those challenges. You know, you could spend an hour just introducing people to string types. Like, that's just how much there is in the primitives in Rust. And then an hour on match and all this other stuff. You know, this was a whirlwind tour to try and show you some of the features. And I hope that it gives people, or at least piques your interest enough. They're like, okay, this seems like a cool language. But not only that, but I understand why I would want to use Rust over other languages in certain use cases. Like that memory safety and data race guarantees are going to help you write software that works rather than crashes. And that's really, really important, especially in, you know, as we all adopt microservices and cloud native, like we've got all this code and we want as many guarantees to its correctness as possible.
Yep. So I think that's pretty interesting, because there is a lot of, I mean, it's not only the hype. It actually offers some of the really cool things that David just mentioned. So I think it is the right time to get involved within the language and to get involved in some of the cool projects that are getting built out there. And there is even a Linux kernel implementation that is happening in Rust. So there are a lot of places things are getting rewritten. There is an issue on the Kubernetes repository for writing in Rust. So a lot of things are there. And there's Wasm, and then Cube projects like KubeWarden are there. So you can use WebAssembly, and you can build out policies based on that, and Wasm will be it'll be compiled to a Wasm code, and then you can run it. So I mean, a lot of use cases are there which can then let you maybe entrust basically not only for programming, I mean, not only for learning, but obviously in the cloud native ecosystem, it is now getting a big presence. So that said, I think I will be definitely working more on learning Rust, and obviously we'll push David again to with some of the streams. Yeah, by the way, we will learn Q, so David will be teaching us Qlang as well, just day after tomorrow, same time, same place. So you can tune in day after tomorrow as well for learning Q. So a lot of things are getting planned, and we both will see you, the audience, on different platforms, either on Rock Code Academy or on my platform. But we'll be together doing a lot of things together in future, because we are in the cloud native ecosystem, and the ecosystem is huge, and we are learning ourselves and trying to explore things, and then trying to let you know what we have learned, so that we all can learn and collaborate together to build cool things. So that being said, do not forget to subscribe, youtube.com/rawcode. That is very important. So you will be definitely missing a lot of good content if you're not subscribing. But I'm sure if you are on this stream, then you definitely have seen all the streams that David has been doing. We have a cluster D episode as well, which would be really fancy. So it is CVO versus container solutions. So it's on 8th of July as well. So just after learning Q, we'll be breaking and fixing the clusters. So 8th of July is going to be busy for me. So that would be interesting. And make sure you subscribe to my channel as well. That motivates us to do more and more content, because it actually takes a lot of time out of this regular schedules to build something, and to showcase them, to compile all the streams, thumbnails, then the video processing, then sitting before couple of minutes, not couple of 15-20 minutes before that. So all these things goes into the planning phase, implementation phase, and the post phase as well. So the only support that you folks can give is by subscribing, by joining it live, and commenting that you have done. So we had some awesome people, Carlos, Nuno, Suman, Neol, Sangam, and all of them. So these are actually the awesome folks in the cloud native community as well. So would be really glad that you just keep on joining, and we all learn together, because I also am used to see all the faces again in all the streams. So thank you all for tuning in, and be sure to check out Raw Code Academy and join that as well. There are a lot of cool perks around that. So you want to talk about that, Raw Code, for a couple of minutes?
Yeah. I would love to. My brain is.
Come on, you have to market yourself, right?
Yeah, I mean, Raw Code Academy is, we're 160 videos, and now they're all 60 to 90 minutes long. Focusing on just all these cloud native projects. Like, there's just so many of them out there. They're all hands-on sessions like we did today. I like to just get into my terminal, get into my code editor. Although in Raw Code Academy, I generally have the maintainers of the projects join me and then guide me through that journey. So you get to explore cloud native projects, watch me attempt to learn them and consume them in various ways, but at the same time have that maintainer there to give us history, context, and flavor, and fix all my bugs when I break it. So it's hopefully interactive and engaging learning experience for cloud native, much like what Siam is doing. I think our content is so complementary, and it's a pleasure to be here and do this. Please join, check out the videos, and hopefully we all learn something.
Yep, absolutely. So make sure you learn, because as Raw Code said in the beginning, the CNCF landscape is is so huge that even if we both do more than 2 streams per day, still we'll not be able to complete all the topics that are out there. So probably it's best you keep on seeing both of the channels. We try to do stuff on both of the channels, so just support us by subscribing, joining, and all those things, and keep sharing them with your friends, and keep learning. So thank you all. See you tomorrow. Tomorrow there is a stream, very interesting one on KCP, a very new project that people are experimenting with. So let's learn KCP tomorrow at the same time. And till that time, see you all. Take care. Bye.
Thank you, Sam.
Thank you, Rockwood.